All right, so we're going to take a look at some more examples of writing functions given sequences of transformations. So for this one, we're going to, again, take x squared and apply the following sequence of transformations. So the very first thing we're going to do is we're going to stretch the graph horizontally by a factor of 2. So remember, with a horizontal stretch, we replace x, our input, with 1/2 x. So remember, it's the reciprocal of the factor for a horizontal stretch. So instead of x squared, it's going to be 1/2 x in parentheses squared. And we need the parentheses because if we don't have the parentheses, then we're just multiplying x squared by a half, which is actually a vertical compression by a factor of 2. Okay, so if we take a look at example 2b, we have our f of x equals x squared. So for the first step, we want to have a horizontal stretch by a factor of a half. So if we replace the x in the f of x with 1/2 x and square it, notice that it stretches it out by a factor of 2. So for instance, here we have a point on the graph that is at -2, 4, and it's 2 spaces away from the y-axis. Well, after a horizontal stretch by a factor of 2, now it's twice as far away from the y-axis, so now it's 4 steps to get from this new point to the y-axis. So now we're going to take this result and then we're going to shift it right 1 unit. So shifting right 1 unit is going to replace this x with an x minus 1. So we get 1/2 times the expression x minus 1 in parentheses, and that whole expression still being squared. You don't have to go through and multiply everything. You can just keep it like this. It's perfectly fine. For shifting right, we can replace this input x with x minus 1. So we take that graph, and now we've shifted it to the right 1 unit. So the vertex was originally at the origin. Now it's at the right one, to the right 1 unit, as is every other point on this blue graph. Next up, we want to reflect this across the x-axis. So remember, when reflecting across the x-axis, we multiply our entire function by -1. So we're going to just take and multiply this entire expression by -1 and get negative that expression. Next up, we want to reflect this blue graph across the x-axis. So we'll multiply the entire function by -1, and there's our reflection across the x-axis. And then finally, we're going to shift this thing up 2 units. So again, shifting up, a vertical shift, we're just going to add 2 to this previous result. So we're going to keep this previous result, and then we're just going to add 2 at the end. And here is our final function for g of x. Now we want to move this thing up 2 units. So if we do +2, we'll have our graph shifted up 2 units. So here is our final graph for example 2b. All right, next up, again, we're just going to reverse some steps here. We're going to get a different function. So now let's start by reflecting across the x-axis. Well, we're just going to multiply x squared by -1, and that's going to give us -x squared. All right, for example 2c, again, we've switched some of the steps in the previous example. So for our first one, we want to reflect the x squared graph across the x-axis. So we said that's multiplying by -1, so we get -x squared. And there's our original graph in red flipped over to the x-axis. Then we want to shift this up 2 units, so we're going to take this -x squared, and we're just going to add 2 to it, and we're going to get -x squared plus 2. Next up, we want to shift our graph up by 2, so we're just going to add 2, so we get -x squared plus 2. Next up, we're going to stretch this by horizontally by a factor of 2. So again, we're going to replace the input x with 1/2 x. Remember, horizontal stretch is multiplying the input by the reciprocal of the factor. So 1/2 x in parentheses squared. Again, we still have this negative outside and the +2. For our third step, we want to stretch it horizontally by a factor of 2. So again, we're going to replace the x with 1/2 x. And again, it widened out the graph, so now it's twice as far from the y-axis as it was originally. And then finally, we're going to shift this right 1 unit. So again, we're going to replace our input x with x minus 1. And here we have our final function for g of x. And then for our final step, we want to move it to the right one. So we're going to replace this x with x minus 1. And there's our graph of g of x for example 2c.